So welcome everybody. My name is Frank McKenna. I'm joined here today with Wael Al-Haddad. The topic of today's seminar is Application Framework for Regional Loss Estimation. Our work is done here at Berkeley as part of the NHERI SimCenter, which is funded by the National Science Foundation. Some upcoming events, just to advertise them. For those of you who are interested, in the next couple of weeks, we have a number of interesting seminars on UQ and AI, specifically targeted towards those working in natural hazards. Also, we're going to have a high-performance computing demonstration of a regional event simulation of an earthquake. So let's talk about today. I've got basically we're going to do three things. One, I'm going to give you an overview of the SimCenter. Then I'm going to talk about the SimCenter, the application framework that we are actually developing. And then, as an example application that can be developed using our framework, we're going to actually specifically spend a lot of time talking about an application framework for regional loss estimation for earthquake events. So the SimCenter, basically it's led and directed by a number of senior faculty. The co-directors are Greg Dearline and Sanjay Govinji, who's actually the PI on the project. We have a number of postdocs working on this project, and we also have a number of faculty members from different institutions around the United States. So what are we exactly? In NSF's eyes, we're actually an experimental facility. We consider ourselves to be a virtual experimental facility. What we are doing is we're producing software applications and providing educational activities, and those are aimed at advancing research in natural hazards engineering. So what are the applications that we're developing? If we look at the grand challenges that over probably 1,000 professors got together and looked at all the different grand challenges and the different natural hazards, they all came to similar conclusions in all these different reports. Basically, the applications we develop have to change from being deterministic applications to applications that produce uncertainty quantification in the output response. The applications, they also want applications that perform performance-based engineering, not just for earthquake, but also for wind and water events. And also applications that deal with the big picture, community resiliency. How does these hazards affect a large region, and how does that region recover after the disaster? Finally, they also recognize the important need for developing educational applications that will educate our next generation engineers working in natural hazards. So that's what we're doing. So as part of our effort, we're developing educational applications. Each year we've promised to develop 2 educational apps. So far we've developed 4 that are available to download. But probably the reason why you're all here is you're interested in the researchers applications that we are developing. We're developing a number of research applications. UQ-FEM, which is an application to enhance or imbue existing FEM applications with UQ capabilities. We're also providing new applications for earthquake engineering and wind engineering. An application for performance-based engineering. And this RDT, basically an application for regional resiliency. This is the schedule for the release of those research tools and the RDT. Now today I'm going to be talking about this regional earthquake version 1 June 2018 application that we have developed using our framework. Because ultimately, how are we doing this? So now I'm going to talk about the SimCenter, the application framework, which is basically behind all these applications that we're building. We'll be using the SimCenter framework. So the SimCenter is developing an application framework that will enable the creation of scientific workflow applications for researchers working in natural hazards engineering. So what are we doing? We're developing interfaces, code that meets those interfaces, and applications. The applications are designed to be both flexible and extensible, so researchers can come along, modify the applications, or add their own applications to the framework. So many of you are familiar with OpenSea, so I like to explain what the framework in terms of basically OpenSeas. So what is an application framework? Basically, a framework is a collection of software for building applications in a specific domain. The framework defines interfaces, the components, provides codes that implements the components, and then finally provides example applications that can be developed using the framework. So if I'm using OpenSeas as an example, OpenSeas is really a framework. It defines interfaces, for example, materials and elements. We provide applications, for example, OpenSeas.exe or OpenSeas-MP and OpenSeas-SP are example applications that are developed using the OpenSeas framework. And we allow people to, both provide new materials and elements, thereby extending the framework. And we also allow people, people use the applications. They provide their own input files to run their own specific simulations. Now, what's different about the SimCenter applications is they're actually workflow applications. So what is a workflow application? A scientific workflow application is basically, we're taking multiple applications and stringing them together, and we're automatically taking the output from one or many programs and providing them as input to another program. So there's no human intervention here at all. The data is automatically passed from one program to the next. So the SimCenter classes, if we go back to the OpenSeas analogy, they're actually applications now. Of course, existing applications don't fit together. You can't take existing applications, take the output, say, from OpenSeas and feed it directly into PACT. It doesn't work. So the SimCenter, we're defining these nice interfaces that each application must meet so that it'll fit nicely into the framework. And of course, everybody wants to use existing applications. So what we do is we provide wrappers around existing applications, where we provide code that'll take the input that the framework expects and turn it into the input that the program is looking for. And then we take the output that the program generates and we put it into the output format that the SimCenter framework requires. And then finally, we've got some additional inputs and outputs that the application needs. So this is an example of one application developed using this new SimCenter framework. We call it the Workflow for Regional Earthquake Response, and it's available on GitHub at the following URL if you're interested in downloading the source code. And this is an example of one run that we've done with this, one example run that we've done with this application, where we've taken the Bay Area buildings, we've got some input ground motion, some seismic simulation. We combine the two to produce some output, and then we compare that output, say, with the recent Haywire event. Will will talk about this in his presentation. But let's say the inputs to run these seismic simulations, these seismic events, these regional events, it's basically an input file. It's like an OpenSeas input file. So every time if you want to run the workflow with for a different region or for a different earthquake, you basically modify your input file and then submit that to the application, and the application will run a different simulation. So again, the applications, this file, this input file, it's a funky format. It's in a JSON format, but in there it defines what the applications are that you want to run inside this workflow. So we're running multiple applications sequentially in this workflow. And this part of the file shows you what that is. And inside that file, for every specific application we want to run, we have basically the inputs and outputs that program needs, in addition to what the framework provides. The little black boxes on top of the jigsaw pieces I showed earlier. So to change the workflow, if I want to run a different simulation, I basically go to my input file and I make a change. Okay, now I can run a different regional simulation. Instead of using the results from Lawrence Livermore SW4 program, I'm going to use OpenSHA to do my simulation. So how do I do this? With the application, there's a configuration file. It needs to know when it sees what an application the event application name and the input file. It has to know what application do I actually run. So it goes to a configuration file. And this configuration file, that application has to be defined in the configuration file and basically the location of the application to run. Okay? Now, by providing this configuration file external to our application, we're not building this configuration file in there. We allow researchers, such as yourselves, to come along with their own application, add it to this configuration file, and then they can modify the input file to use their application, and it should just run just fine. This is kind of what the sequence diagram looks like for our for a running workflow. Basically, we start off, we get the buildings, then we go get the event, then we go to structural analysis model, we go get the engineering demand parameters we want to simulate or record in our simulation. Then we perform the simulations and we go get our damage and loss estimation. Say, for example, we're just doing a damage and loss assessment. But ultimately, all these red boxes, they're files we're passing around between the programs. So this is what we're handling internally when we actually run our simulation. And on top of this whole thing, to complicate matters, we throw uncertainty quantification around the whole thing. We don't, for example, we've got our building models. We don't know the heights of the buildings exactly. We don't know the mass of the buildings exactly. We don't know the ground motions exactly. So there's a whole bunch of uncertainty involved. We throw uncertainty quantification around the whole thing. So I'm going to get into more specifics about the particular regional earthquake simulation, and Wales going to do that in the next presentation. But just a quick reminder, so I'm talking about, what Wales going to talk about is this regional earthquake simulation application that we've developed. It is a workflow application. It takes input files, which you can modify to run different applications. And if you want to extend the application, you basically have to go to the configuration file and add in your new app. If you got some new application, you would add it to that configuration file. And as long as that application meets the input and output specification for the workflow, the application will run just fine in this workflow application. Now, ultimately, this time next year, I will have this RDT tool. All the RDT tool is going to do, it's a desktop application. It will have different bars on the left for each of the different applications that we can run. When you select the bar, it's going to ask you for the input parameters for that particular application that are unique to that application. This application will then create a JSON file on your local machine. It will then run that job either locally if you want it, or it will run it at DesignSafe on the Stampede 2 or the Wrangler system. And then it will take the results back and present them to you. So that's the RDT tool planned for release next year. And now we're going to hand this over, and Wales is going to present specifically about the regional earthquake simulation application.
Thank you, Frank. Thank you, Frank, for the introduction and the overview. So in my presentation, I'll be actually focused on the application framework. So I will be talking about the different workflow applications that are currently provided with the framework. I'll also talk a little bit about the abstract definition of each application, what each application does, and I'll also talk about the interfaces between these applications, the different files that Frank was talking about. And after that, we'll talk about the test bed. We have a test bed for the San Francisco Bay Area that we use to kind of exercise the workflow and see how it works. And we'll also have a demo to show how to run this workflow on a local computer for a small number of buildings, of course, just to demonstrate how it can be configured and what the outputs look like and how it works. And at the end, we'll have some time for questions and discussion. So if we look at the workflow, Our main objective is to do a regional simulation where we have a region of interest subjected to a hazard scenario, and we're interested to estimate the damage and loss that happens to the region. So basically, in other words, we're mostly focused on buildings at this point, and we basically have a building database for the specific region that we're interested in, and we just run the region simulation to estimate damage and loss. And if we break this down for a single building, then the workflow basically starts from a building information model. So out of the building database, we pull one building, and this gives us some information about the building, things like the number of stories, the area, the year it was built, and stuff like that. And given the hazard scenario, we compute or evaluate the event input on that building. And then we go through the process of creating a structure analysis model to find the building response, and then we can do damage and loss estimation. So basically what we see on the screen here in this workflow, so for every single building, we need to obtain these 5 different files. So basically for this presentation, for the rest of the presentation, all these parallelograms with light yellow background and light blue color, these are input or output files. And so we basically have these different files: BIM, event, SAM, EDP, and damage and loss. And I'm gonna go through a little bit more details about the applications and the interfaces and how it works. So starting from a building database, we need to go through the first process of creating a building information model. And given the building information model, information about the location of the building and the year built and things like that, we can basically use the create event process to find the event input on this building. So let's say we're considering an earthquake scenario, so giving the building location and how far it is from the earthquake rupture, we can use some models to evaluate the ground motion or the event input on the building. Of course, for a different hazard, it may not just be the location that's needed to evaluate that, it might be also the building geometry or the dimensions. The next step in the workflow is to create a structure analysis model to be able to compute the building response and create the EDPs based on the event we're considering. So for seismic events, we have particular EDPs that are important for loss assessment. After that, we perform the simulation, run a finite element model, let's say, and we get the values of the EDPs. And at the end, we do loss estimation using all of these files. So this gives you the overview of the workflow. So we have basically 5 different files which we consider as the interfaces between the different applications. And we have 6 main applications here. And now if we want to introduce uncertainty, we introduce another application called Perform EQ, which Frank talked about briefly, and we'll talk about it in a little bit more detail later. But basically, we would like to be able to introduce uncertainties in all of these applications and be able to propagate the uncertainties in all of these files that we produce. And so basically, we have 7 types of applications in the workflow. I'm gonna talk a little bit about the currently registered applications. And by registered, we mean they are available as part of the source code. They have been integrated with the workflow, and we have tried to demonstrate that they work. And these are the different applications that we have. So if we talk about a create BIM application, we have 2 different implementations that we provide with the workflow. One of them is the generate BIM database, and the other one is Urban Sim database. The first one uses just a simple flat file to define the building database, and the Urban Sim database takes building information from Urban Sim simulation outputs. We'll talk about each one of these applications in details, but I just wanted to give you guys an overview of what is the list of current applications that are registered with the workflow. For creating a seismic event input on the building, we have 2 other applications as well, and one of them uses outputs from SW4, which is a 4th order seismic wave propagation application, and the other one uses seismic hazard analysis and record selection and scaling to obtain the ground motions. And then for CreateSam, we currently have one implementation that was provided by Professor Jinjing Lu from Tsinghua University. And that application creates a multi-degree of freedom shear building model. We'll talk about this too. For EDPs, we have a standard earthquake EDP that defines the peak floor accelerations and story drifts as the EDPs that are needed for this earthquake application. For performing the simulation, we use OpenSeas to get the ETPs, and for loss assessment, we use an application that was also contributed by Professor Lu's group, and that application basically uses the FIBA P58 procedure to estimate the damage and loss. And finally, for doing uncertainty quantification, we have one implementation that uses the quota that propagates the uncertainty in all the applications. So I'm gonna talk about each one of these applications and implementations in detail. So if we start by talking about the CreateBib application, basically the purpose of CreateBib is we want an application to pull the building information model from a database. So in this case, we see on the right-hand side, this is just a sample building information model. It has some basic information about the building, things like the year it was built, the number of stories, the square foot area, the height, and occupancy, and the replacement cost and location. And we basically want to obtain this BIM file for each building in the region. And this is the first interface file, basically. So if we can obtain a building information model in this format, the rest of the workflow can use and consume this information and use it for the rest of calculations in the workflow. So this is the first file that we define here, a BIM file that includes this basic general information about the building. And one of the implementations we have is just a generic database file that uses a flat CSV file that you can provide. So you need to obtain this information, basically the area, the number of stories, the year built, the type of the building, basically the occupancy type, and the location. So if we have this information and we can use this generic BIM database to obtain BIM files for each building in this region of interest, and this application will also have to make some assumptions to obtain some of these values. So if we look at the input here, for example, it doesn't have replacement cost. So we'll talk in a little bit about what kind of assumptions these applications would use by default and how they can be configured. Another application that can be used for creating a BIM file is UrbanSim database. And what this application does, it takes the outputs from an UrbanSim simulation and use that to create the BIM file. I'm assuming some of you guys might be familiar with UrbanSim, but if you're not, UrbanSim is basically a platform to model and analyze urban development. So for example, if you can think of a case where you are interested in studying a region under the effect of a hazard, but you're studying this region in the future. So basically in the future, your building inventory and population and many values that you need to use in your study might change because of how this urban area develops. And because of that, you might be interested to use some of these urban development tools to study the region, let's say, in some time in the future. And basically, this is one of these applications that would use outputs coming from UrbanSim and provide the same building information model that we're talking about. So this is kind of demonstrates what Frank was talking about. So you might have an existing application and you try to create some wrapper around it that no matter what format of data it has, it will still output the data in a format that the workflow can use. And this basically, allows us to create this standard interface that can be shared between different applications. So for both of these previous applications that I mentioned for creating the building information model, there are some assumptions that are being used to do things like structure type mapping. So when we're talking about a region with hundreds of thousands or millions of buildings, it might not, we will not have all the data that we need. So for instance, the structure type, the material that was used in some of these cases are not available. So in these applications, by default, it maps the occupancy and the year of construction and the number of stories to different structure types. And this is the default mapping in the tool, but it can be controlled by a configuration file. So if you have a different region of interest and you want to change this, that's possible. And in some of these cases, the structure type, the mapping is done to more than one structure type. In these cases, structure type becomes a random variable and it gets sampled, and it will be assumed that all of these types are equally likely in that case. Another assumption that goes into creating this building information model is the replacement cost. It's currently in this application based on the hazard default valuation, which actually comes from RS means. And basically the way they do it is they specify the replacement cost per unit area in square foot, depending on the occupancy, and they have a factor for the contents. So the contents replacement cost is a factor of the structure replacement cost, basically. And again, these values are the default, but they can be controlled by a configuration file. The next application in the workflow is the create event application. And now that we have obtained the building information model, we would like to use a create event application to get the event input on the structure. And in this case, because we're talking about seismic hazard, then the input on the structure is basically a uniform acceleration, the ground motion basically. So we need things like the number of steps in the record and the time series and the time step and so on. And we need the ground acceleration in different directions. So this is what this event file provides. This is just a sample of what type of information it might include. And again, we have two different implementations of this. One of them uses results from SW4. It's called NL SW4, and SW4 is a 3D wave propagation simulation for seismic waves, and it can be used to simulate earthquake scenarios. And it's developed in the Livermore Lawrence National Laboratory, and in addition to that, we also had collaboration with Professor Arthur Rogers from LLNL, and we also have we obtained some data for a magnitude 7 Hayward earthquake simulation, and we can use this, for example, in our simulation. And the way it works is the results you get from these simulations can be defined at a grid of points over the region of interest. And basically this application will do a nearest neighbor search and find the nearest site with ground motion coming from the simulation and use that as the event input. And another alternative for defining the event input on the structure is another application we call SHAGM. And this application basically uses seismic hazard analysis and ground motion record selection and scaling to find ground motions at, again, this grid of sites across the region. And basically it creates a grid and it finds the ground motion at each point, and then it uses, again, nearest neighbor search to do the analysis of the building. And for this application, we might need to provide more information, things like the earthquake rupture, the geometry and the magnitude, and ground motion prediction equation, and database of ground motion records, such as PRNGA West 2 records, for instance. The next step in the workflow is create SAM. And SAM, or a structure analysis model, is basically a file that has the geometry of the structure analysis model, things like nodes and elements, and also the structure and material properties. And this is just a sample of how it might look like. And we have one implementation in the current workflow that's registered. It's called MDIF Lu. As I said, it was provided by Professor Lu, and there is a reference here for how this application does the modeling. And basically, this application creates a nonlinear shear building model, and it makes some assumptions, such as all the floors are having the similar mass and height and stiffness, and it also considers some uncertainty in the stiffness and damping. After that, the next process in the workflow is the create EDP. We have one implementation, which is the standard EDP is used for earthquake engineering. And after that, the next step is performing the simulation. And the current implementation in the workflow is the OpenSea simulation. This is a sample file of how the ETP looks like. And after we perform the simulation, basically this file gets updated with the values of the EDPs. Things like the peak flow acceleration, the drift, and the residual displacement. The final step in the building workflow is basically doing the damage and loss assessment. So given the building information model and the EDPs that were evaluated, we can use the FEMA P50A procedure to estimate the damage and the consequences, the losses, the downtime, the red tag probability, and so on. So we have here the repair cost, the loss ratio as well. So in the workflow, we currently have one registered application, again, also provided by Professor Liu. And the application would take as an input also the ATC curves and files that define the normative quantity for the components of the building, both the structure and non-structural components. And these files can be configured as well. And it estimates the damage and loss for the building. So we went through the 6 basic applications in the workflow. There is one more application which handles the uncertainty. It's what we call perform EQ. And basically what this application will do is it will call all the other applications. And whenever one of these applications define random variables, it will start sampling them. So I'm assuming here, let's say we have a building information model that define random variables and a structure analysis model that define random variables. For instance, we can have a height as a random variable and stiffness and damping as random variables. Then the uncertainty quantification application will basically create different samples. And for each sample, we have the whole building workflow. So starting from the BIM, event, SAM, EDP, and damage and loss. And at the end, we combine the damage and loss estimates for all the building samples. So this is how UQ is handled in the current workflow. The last thing is that this workflow can be configured. I think Frank went over this quickly, so I just wanted to point out a couple of things. There are 2 configuration files involved here. One of them is the registry. It's where different applications are being registered that can be used in the workflow, and just a configuration file for the workflow. And the way to run it is just to call the Python script for running the earthquake simulation for the region and pass in the configuration file and the registry file. So we have actually exercised this regional simulation workflow on the San Francisco Bay Area. So we obtained the magnitude 7 earthquake simulation using SW4 from Dr. Rogers and his colleagues, as I mentioned. And we had an inventory of 1.8 million buildings coming from UrbanSim. And we used damage and loss calculation provided by FEMA P58 and the structure analysis model, the multi-degree freedom shear building model, also provided by Professor Liu's group. And we made sure all of these applications satisfy the interfaces for the SimCenter framework. And we were able to run the simulation. And the results shows 141,000 buildings that are red tagged and a building damage of $84 billion and damage ratio, a net damage ratio for the whole region of 5.6%. So you guys can see in the figure, there is a lot of red colors in the East Bay. That's because it's on the Hayward Fault, so it's in the East Bay area. So this is just a visualization of some of the results we get. So you can see that these results are actually on the parcel level. There's loss ratios for San Francisco and Alameda counties and the red tag buildings in the East Bay. This is visualized in QGIS, and the only thing I want to point out here is that the results obtained from this workflow are on the building level or the parcel level, basically. So they are fine-grained, I would say. There was another study called the Haywire scenario, and that study uses hazards for the loss estimation. So we wanted to have some comparison between running the test bed that we had for San Francisco and other studies that does the similar thing. Unfortunately, we can't do a one-to-one comparison because both studies included different building inventories, but it's still a comparison that would show us how far things are. So in the Hayward scenario, they considered different counties in the Bay Area, so they had 3 million buildings. Some of them were a little bit far from the rupture, actually. And if we compare red tag buildings, so they concluded 100,000 buildings will be red tagged. The building damage in the test bed that we had was more than double of the one in the Hayward scenario. The net damage ratio, the loss ratio also is higher, and the total building cost that we included was higher as well. So the building inventory was a little bit different, but we can at least see that it's not one order of magnitude difference. So there is still some comparison between the two studies, I would say. But there is an ongoing effort on doing more detailed comparison between the two studies. So right now I'm gonna do a demo. So my plan is to actually do a live demo. I have a recorded demo just in case things goes wrong. So I'm gonna minimize my presentation and do a live demo. So this is the workflow folder on the right-hand side here. So we have this regional earthquake simulation Python script. This is how we run the workflow. And this script needs to read two different files. The first file, as we mentioned, the application registry. So I'm gonna open this one to show you guys what information is in there. So this is basically defines all the applications that are registered that can be used. So we have, for example, for the building information modeling, we have the urban SIM database application. And we have the generic Vim database application that we mentioned. It also shows where this application can be found and any specific inputs that this application takes. So this application takes a building file, for instance. And just some other example, let's say the MDOF Flu application is available in this location, or the standard earthquake EDP application is available in this path, and so on. And so this way you can add your own application by defining where the application is found and what kind of application data needs to be passed. So this is the application registry. I'm going to show you guys also the configuration file. So this is the configuration file that we use for creating a workflow. So this file will basically do loss estimation for 10 buildings in San Francisco Bay Area. I'm just choose a small number of buildings because we wanted to run something quickly and see the results. So for this workflow, for this particular workflow, I'm using generic Vim database, and I'm pulling the building data from a CSV file that I have on my hard disk. And this will be running locally in a little bit. I'll start running it. And for this workflow, we're using the Hayward 7.0 earthquake simulation that I was mentioning earlier. For the modeling application, we're using MDOF Flu, and this application needs some data from HAZUS, so we can point it to any application-specific data that it needs. We're using standard earthquake EDPs, we're using OpenSys for simulation, and we're using FEMA P58 LU for the damage and loss assessment. And for handling uncertainty quantification, we're using Dakota, basically. So I have all the files I need to run the workflow. So what I'm gonna do is I'm gonna call this Python script. And I'll say run demo workflow, and I'll provide the application registry. And this should run the workflow for the 10 buildings that we were talking about. So we just have a small database of buildings. You see it running building 1, building 2. While it's running, I'm gonna show you guys what files it's producing. So it created a folder for the demo workflow that we're running here, and it started creating the files for all the buildings. So things like the building information model. So in this workflow, we we have a building information model that defined the height as a random variable with a specified mean and standard deviation. This first building was a residential building, and the structure type was it's timber structure, and it calculated the replacement cost, the replacement time, and so on, and the location of the building too. So for this building, it actually went through all the computation and obtained the damage and loss estimates. So this building has a 0.5% median loss ratio, and repair cost, the mean repair cost was $4,600. So it has done that for all the buildings, basically. Just to give you another example, this is another building, and this one has a slightly higher loss ratio, 7.3%, and the red tag probability is 11%. And we can see here that it went through this workflow for all the buildings. It ran 10 files and generated a log file that we can look at. If something goes wrong, we can use it for troubleshooting. So it generated all these files for the buildings, the files that we talked about before, the BIM, SAM, event, EDP, and so on, and the damage and loss file. I intentionally let this workflow leave all the intermediate files so we can see what happened actually. So it created a folder for each building, created a template directory that have files that defines the random variables, and it ran uncertainty quantification. So that's why we see here different working directories that were generated. So for this building, just to run things quickly on my local computer and demonstrate how this works, we just had 5 samples per building, which may not be sufficient, of course, but this just demonstrate how it works. In each one of these folders, this is a sample of the building where the random variables have been assigned values. So for instance, if we open the building information model, we see that this random variable for the height has been assigned a value of 2.79. The average was 3, if you guys remember. And that's basically how it works. It will sample the random variables and go through the whole workflow and generate all the files. You can see here there is an OpenSeas model that was generated, and it created all of these outputs, produced all of these outputs. So this is basically how the workflow works. I'm going to show you that also it has some post-processing tools that can aggregate all the data. So for all the buildings that we have a table basically of the repair cost, the downtime, and the red tag, if any, and the loss ratios and the locations. This kind of file is suitable for consumption in GIS tools. So this is how we actually created those plots and visualization that we showed earlier in the presentation by using these CSV files. That basically is my demo, but before ending the presentation, let me tell you guys about the resources that you have. So if you're interested in using this workflow, you can check the source code of the workflow on GitHub. We have links here in this presentation. And we also have documentation for the workflow that's posted on the website. And we use, for the most part, we use Slack for communication. We have a channel in the DesignSafe Slack account for the SimCenter earthquake workflow. This is a link for the channel, and also this is a link of how to join Slack on DesignSafe. So if you guys are interested, please join us there, and I think that can be very useful discussion on the workflow. So before I end my presentation, I would like to give some acknowledgements. We would definitely like to acknowledge Dr. Rogers and his coworkers at the Lawrence Livermore and Lawrence Berkeley National Labs for providing this ground motion data for the magnitude 7 earthquake on the Hayward Fault. And we would like to thank Professor Jinjin Liu and his research group for contributing implementations of CreateSAM and CreateLoss applications. And we also would like to thank Professor Jack Baker for his discussions about seismic hazard analysis and ground motion spatial correlation models and record selection and scaling. And we also acknowledge the contributions of OpenSHA, which is a library developed by SCAC for seismic hazard analysis that we use by one of the tools we have. And we definitely want to acknowledge the support of the National Science Foundation that funded this project. So now we can start questions and discussion. The way this works, we actually have quite a large number of participants, so it will not be possible to allow everyone to unmute because it can get a little bit confusing who's talking. So the way it works, we'll ask you guys to use the raise hand tool. So basically, if you go to the participants list, you'll find a small button at the bottom of the list that says raise hand. And if you raise your hand, it will show up for us. And I'm not sure if you guys can see this, but this is basically the list I'm talking about. If you don't see it, it should be on the lower panel in your Zoom application. You can click on participants. You can go there and raise your hand if you have a question, and we'll be able to unmute you, and you will be able to ask your question. And you can also, if you want to type it down, that's also fine. You can type it in the group chat window, and we'll just relay the question and answer it. We have still like 12 minutes or so.
So if there's no questions, we'll end this.
I saw Professor Govinci. Okay, there are some people who raised their hands. Just one moment. I think, okay. Professor Govinci, and I think I unmuted Professor Govinci and also someone else, yes. There are 68 participants, so I'm pretty sure someone has some questions. But I can see. Okay. So there's someone raised their hand, but it looks like they may not have a mic, so it's not allowing us to unmute them, because it's not showing here that they have a mic that is muted. So, so someone with the name BL. So if you can check your mic, just make sure you have a mic set up and we'll be able to unmute you.
Can you hear me well?
Yeah, we can hear you.
Okay. Can you say a word about what someone would have to do if they don't want to run it locally, but they'd like to use the DesignSafe?
Yeah, so at this point, they can get the source code, they can build it. We have a guide on how to build this, and they can build it and run it on DesignSafe if they have allocation. We are actually working on providing this as a Agave application where people can invoke it using the Agave API, and we'll probably wrap some UI applications around this. But at this point, if someone is interested to run it on HPC, they need to have their own allocation. They can get the source code and build it. Should be pretty straightforward. And that's how we did it for the testbed. And if they need particular data, they might need to bring this into their own allocation and they will be able to run their simulation. So the source code is provided, it's open, anyone can get it and run it.
So they would have to bring it into their workspace on TAC, compile it, and then they could run it.
Yeah,
yes.
But this process is pretty straightforward. We have step-by-step guide of how to do this in the documentation and also on the GitHub repository.
Okay, there's some questions appearing in the chat, so you can look there.
Okay. So someone asked, how could we have access to this webinar later? So this webinar is being recorded and we will post it on the DesignSafe YouTube account, I guess. And it should be available through the SimCenter website too. I don't know the timeline for posting this, but it should be in a couple of days, if I have to guess. So it will be posted online. Someone asked, how would you run it non-locally? So I think, okay, that was Professor Govinj. Someone also asked how to get our own HPC or allocation of tech resources by DesignSafe. Oh, that's a post by Tim that shows how to get this allocation.
If you want an allocation to run this in the HPC, basically go to DesignSafe and just search for allocations. And it should bring up an allocations policy page, and you'll find the information there.
Someone asked, out of the 1.8 million buildings in San Francisco Bay Area, how many had the FEMA model building type before you performed mapping to fill in the missing data? So in that simulation, we didn't have building types in the test bed. So we had occupancy type and the year of construction. So we basically mapped the structure type based on the mapping that we showed in the slides. So for some of them, it's a one-to-one mapping. For others, it becomes an uncertain property because we don't know. So that basically gets propagated as an uncertainty in the regional simulation. Of course, if we have this information and if we know more information about the building inventory, we can modify the applications so that they don't do the mapping for a building that has a known structure type, let's say. Someone said, Professor Lowe said, if I wanted a student to eventually expand on the simple model you are providing, how would you recommend that they start? What are some easy modifications to make? What are some more challenging modifications? I guess the way it should work is they probably need to start by just running this workflow locally and understand how it works, and also understand the file formats, because the files are assumed to be interfaces between the different modules in the workflow. And once they are familiar with these file formats, they can basically remove one of the applications and provide their own implementation for the same purpose. For instance, for CreateSam, for creating the structure analysis model, they can write their own CreateSam application that uses different assumptions. So as we mentioned, the one that we have, it just assumes all the floors have the same mass, the same height, and so on. But if we have detailed information, we can come up with a higher fidelity model. Then we can basically write our own application that creates the structure analysis model. But the produced structure analysis model will need to be in the same format that is produced by any. So basically, the formats of the files is supposed to be a standard. And of course, it might evolve as we go forward if we want to support more capabilities or enhance the capabilities of the workflow. But for the most part, if someone wants to get the current workflow and they want to change one of the applications with a different one, the output needs to be in the same format, basically. The documentation for the workflow is actually in this link over here in the presentation. So it's in the SimCenter website. If you go to research tools, and you will find the regional earthquake simulation workflow, and this is where you can find the documentation. There's also some documentation in the GitHub repository, but that's more relevant to people who develop. So if someone wants to contribute to the source code, or they want to bring in their own applications, they want to modify the applications, then that might be relevant for them. Let me see if someone raised their hands by any chance. I don't see.
No hands and no more questions. So if there are no more hands or questions, we'll call it a day. Oops, no.
How can we use this workflow for multi-hazard analysis, for example, earthquake and wind? Frank, would you like to talk about this?
Well, earthquake, we're actually, that's the subject of our second testbed. So we're actually looking at that right now. Basically, we need to get the wind loads on the building. The framework itself, the actual, is set up so that it can handle one event after another. If you actually look at the input file, you'll see that the events are actually in an array. And basically the code will take one event, and then if there's an event following it, it'll run that event. Right now we just need some wind applications to generate the forces on our buildings.
Someone asked, how do you recommend visualizing simulation data? So by simulation, I'm not sure if by simulation it means the OpenSea simulation, but visualizing things like the loss, the damage and loss values and the damage and loss assessment can be done in GIS applications. I'm assuming visualizing anything can be done in GIS tools, but this requires getting the building footprints and also having accurate locations of the building inventory. And we have exercised this process for the testbed and documented it. So if someone is interested in visualizing results similar to the way we did in the testbed, there is a small guide on how to do this in QGIS, step by step, how to import the building footprints, where to get building footprints, how to import them in GIS tools, and how to import the results from the SimCenter simulation, regional simulation, and how to join the layers to be able to do a parcel level visualization. The source code, someone asked about the source code. I think let me send the links in the chat window too. So the source code is available here. But I think this presentation will also be posted on the website, on the workflow page. We can also post it on the Slack chat room. Okay, someone else asked, is there a link to the building database you used?
The full 1.8 million buildings is not available. We have a slimmed down version that we can hand out to people that doesn't contain all the, as I say, the 1.8 million buildings. We're not at liberty to release that one just yet.
Okay, there is another question that maybe we can talk about. So someone asked, how does this simulation take into account the building element model nonlinearity, the damage residual quantification? Is it from current or available OpenSea elements? Yeah, that is the case. So if you look at this reference, it actually goes through the process of creating these nonlinear shear building models. And basically, it uses zero-length elements in OpenSea for the nonlinearity. It's a model that includes also degradation and so nonlinearity and degradation in the structure strength.
We'll skip that one. Can we do the k-dimensional tree offline for NN search? We'll do that offline. Yeah, I think. So I'm not sure. I'm not exactly sure about. Maybe it's possible. It's better or more efficient to use a quad tree, and maybe that's because the grids we shown are uniform, but it's not also necessary. It's possible to have just a group of sites that doesn't represent a uniform grid of points. So that's also possible.
there. That's one possibility, because when you do this process to get the event input, you can pretty much select any. So maybe in a particular location you need more fine-grained points, because you're more interested in this location. In other location, the grid can be coarser or something like that. So, but it is of course possible to find other search methods to find the nearest neighbor. So there isn't a strong preference to using k-dimension trees. It can be done with probably other methods too. Someone asked if the slides are available for download. So
they will be available later today.
Yeah.
Can the framework be applied to every type of building, moment frame, brace frame buildings equipped with dampers? And the answer to that one is that it will be. Right now we're developing a tool that will parse different types of models. The existing model does shear buildings. It also does walls. I'm actually actively writing the code that will handle moment frames and brace frames.
Let's see if anyone has raised their hands. I don't see anyone raised their hands.
Okay, we're now running overtime. So unless there's a question posted, we'll bring this to an end. I want to thank you all for attending this seminar. I encourage you to attend the ones in the next couple of weeks on the AI and the uncertainty quantification, and the presentation by Dr. Rogers on that large simulation. It's actually a quite interesting presentation. I can talk about how they use hundreds of thousands of processors to actually do that simulation. So if you're interested in things like high performance computers, and that's actually a presentation very worthwhile to watch. So we'll call this a day. Thank you, everybody.
Thanks.